Hello everyone, this is Monica. I'm going to take you through my dataset, the exploratory and data analysis on the dataset for solving AI, for solving ill fit in fashion using AI. Basically, I'm going to be presenting a brief on the dataset and the importance of the exploratory data analysis, heat maps, correlation matrices, dot boxes, box plots, feature independent plots, outlier plots, illustration of patterns of interest, illustration of trends in time and space, splitting data, fitting the model, and then hyperparameters and evaluation. The data set I'm using has majorly four features, three of which are supposed to be input by the user, i.e. the weight, edge, and height, and the the size, which is the output got based on the input. Explanatory data analysis helps one to critically understand the features in the dataset, clean the dataset where necessary. Cleaning the dataset can be done by removing duplicates, dropping or filling up the null values. For my case, I cleaned my dataset by replacing all the rows with null values with the mean value. This was for age and height, which had some null values. I also dropped all the duplicate values. The heat maps. Heat maps help us know the relationship between the various features in our dataset. I consider the input values, that's the weight, the age, and the height, since they were numerical. Here in my dataset, you see that the darker the shades, the higher the correlation between the features. So we can look at the height. The ones which are really dark are just those ones between themselves, like weight and weight. The ones which are slightly pink, that's where we have height and weight. I mean, there is some correlation between them. Then the low is between the age and the weight, and then the age and the height. Then correlation matrices provide us with values that we can use to determine the precision, accuracy, F1 score, and recall. When with its values, we are also able to see the relationship between the features in our data set. The values range from strong negative, that's low correlation, to strong positive, that's high correlation. The box plots help us to generally analyze the distribution of numerical values and features. They help us to know the maximum, minimum, median, and quartiles of our features. My box map is for three numerical values in my dataset, that is to say, the weight, age, and height. In the feature independent plots, I had the height versus the age. It was really screwed towards the left. Then I had the weight versus the age. It was also screwed towards the left. Then when we looked at the weight versus the height, that was at least distributed throughout the graph. Then the outlier plots appear at the extreme ends and vary so much from the mean. This can be seen on a plot box. So for this case here, we have the extreme values. They are those ones which are shown with the small zeros, the small ovals. Those are the outlier plots. Illustration on patterns of interest. My patterns of interest were in the height and weight variables because they had a relatively high correlation as compared to age and height, and then age and weight. Illustration on trend and space and time. I generally didn't have anything like variation in space and time because my data set there wasn't any variable that was varying in terms of space and time, so I really didn't do that. Splitting my data. Before splitting my data, I first grouped the features, the input and output XY respectively. The input was the weight, age, and height, and the output, the size, which was in X, the extra small, medium, extra large, extra large. This way actually got depending on the input that one puts. So I split my data set into 3 in the ratio of 14 to 3 for training, testing, and validating respectively. This was done for both the input values x and the output values y. Fitting my model, I use the decision tree classifier since not all my values are numerical. In other words, the input values are numerical, but the output values are not. The decision tree classifier was fitted with X train and Y train values. After fitting the model, we used the X test as the input to get predictions, which were later compared to Y test values to determine the accuracy. The accuracy kept varying as we used the K and 4 cross validation to school the data for training and testing, the ratio of 8 to 2 respectively. However, the range of the values of accuracy was between 0.6, 0.523, and 0.621. Thank you. That's all I had for this time around.